Hello, welcome to SFPUG April 2026 meetup. I'm your host, Catherine Saar. Before we begin, the meeting is being recorded and will be posted on YouTube afterward. Everyone who speaks during today's event will be part of the recording. We will do the Q&A at the end of the presentation. If you choose to ask a question, your voice and image, if you have your camera on, when speaking, will be part of the recording. If you do not ask a question, you will not be part of the recording. If you're using the most recent version of the app, which we do recommend, you can use the raise hand function to join the queue. If you're using an older version of the app, which does not have this function, please use the chat to let the organizers know that you would like to ask a question. They will add you to the queue. The organizer will let you know when you're next in the queue so you can be ready to unmute your microphone and ask a question. If you don't want to be part of the recording, the organizers can convey your question to the speaker. In that case, please type out your question in full and let the organizers know that you would like them to present it to the speaker. If you have any technical issues, please message the organizers for assistance. If you drop out of the meeting and are unable to rejoin, you can post a message on the event page on Meetup, which we are monitoring during the presentation. Excuse me. SFPUG and Bay Area Postgres is a PGUS affiliated user group, and I'm a volunteer for PGUS. SFPUG is sponsored by PGX, and I work for PGX. Thank you for joining us, and here is Monica Sarbu with Databases in the Agent Era.
Having me. It's a pleasure to see you all today, most of you. So can I share my screen now, or?
You should, yes.
Okay.
You should be able to.
Perfect.
Okay. There we go.
Cool. Can you see my screen?
Yes.
Yes, I was just checking. Great. Yeah, so like you said, my name is Monica and I'm working for a company called Zeta. And in the last 2 years, we were thinking how Postgres needs to be changed for the agent era. So what changed? What changed with the agent? So basically, the most obvious thing is that before applications used to talk with databases, now agents do. And actually, they have much different requirements than humans do. And first of all, before we were developers, they chose a database based on like which one is better and which has this and that functionality, which performs better. But now with agents, basically, they need thousands of them. Now, thousands of small databases. Why? Because you cannot really have an agent and point the agent to a single database and not even production database. So it's important that each agent is able to create and access database in an isolated environment. So they are safe to run and safe to break, and everything that the agent does to the database, querying, changing things in the database doesn't affect production, for example, or doesn't mess up with a shared database. And there were so many examples out there. I only gave you only one example here, where an agent was pointed directly to the production database and basically decided by themselves that they have to basically shut down the production database. And there are so many examples, and lately there are even more and more examples that basically I feel like we need to really take a step back and think about how can we provide the infrastructure and Postgres to give agents an isolated database that they can mess up without damaging any production databases. And actually, I think the problem is that they are operating at a different scale. Currently, more than 80% of databases are created by AI agents and not humans. And I think the data is even, old. I think this is even more than 80% now. And I think to make it easier to understand, I kind of chose two use cases where kind of depict better how agents, where agents are mostly used. And first is the AI platform. So basically AI platforms that are creating agents for their users, and they kind of perform different tasks. And often these agents, they have to create a database either from scratch or with data from production in order to do different tasks. And this task can be, as simple as, you have a website that requires a database, or you need an agent that basically query the database and extracts a few information from that and creates reports. Anything, right, that basically we do kind of, and often they have to touch the data in the database. And in order to kind of simplify the kind of the explosion of the number of databases, I kind of chose a simple example. And let's assume that we have a modern AI platform that has 100K users. And imagine that if each of these users creates 10 agents per day, and each of these agents create 10 tasks per day, that means that you need 10 million databases per day. And before we were discussing about one database, but now we are discussing with the agents. In the agents era, if you want, we are discussing about 10 million database. So the scale is really incredible that we are talking about here, right? So 10 million database per day is basically, it means that you don't really need to, we are not discussing about you need a bigger database. We are discussing about, you need millions of isolated databases, and ideally cheaply created, because you can imagine you cannot really create like so many databases and be still in business as an AI platform. But the problem is that databases weren't built for this scale, right? So there isn't any traditional infrastructure that allows you to offer isolated database for each of these agents, right? So basically, before, in a traditional model, you had basically a production database that had a few replicas. You had maybe one staging or 2 or 3 staging databases that your developers were using or sharing to test different features. And those were running for years without touching them too much, right? Now in the agents world, we see a different pattern. So all these databases, there are like a really large number of databases that agents require, but they're also ephemeral. So what it means is that you need one, you have to create one for every task, and then you use it briefly and then discard it. So basically, it's just the opposite that you need, right? So not like you don't need databases that live for years. You kind of need databases that live it for a short time, that are cheaply to create, that you fulfill your task in an agent and then drop it. And another requirement is that agents cannot really wait for a database to start. Humans may be willing to wait for a few seconds, but agents can't. So the startup time for these databases need to be less than a second, in my opinion, because they cannot really wait on the database to start. So basically, if you think of like the requirements for databases for agent workflows changed dramatically, in my opinion. So you need to be able to start a database in a short period of time, like sub-second, instantly. You need to be able to hibernate that database when it's idle, and then be able to wake it up immediately when there is a connection to the database. You need, more importantly, you need to be able to create lots of databases for a low cost, and then full isolation, because you kind of need to have your the agent needs to have the database to be able to do whatever it needs with the database or whatever it decides to do, and then drop it at the end without causing any harm to other agents or to the production database. And the second use case is different in the sense that you have all these platforms like Netlify and Vercel. They offer these preview environments, right, where you have a pull request and you want to see how this performs, right? And they don't consider the data, right? And I think it will be this is something that is important for an agent to see how the pull request or how the change that, for example, the coding agent generated performs against the real data in production. And this is something that is different than the previous because it takes into consideration the data and the real data. And it's important, I mean, we know this, that is important for your pull request or for any changes you do to your code to test it against real data and against production-like data. And for this, basically, I'm adding a few more requirements to the list, and this is, the first one would be to be able to use real data. And then also another requirement is that, once you give real data or production-like data to all these agents, it's important that you don't leak sensitive information. So we need a way to safely handle PII information. So definitely, I think this is obvious by now. Cloning production doesn't really work at scale because it takes too long, it costs too much. Imagine that you have a production database that is a few terabytes of data. Cloning the production database for each agent is too expensive. It takes a few hours and you need to have it in less than a second. So it doesn't really scale. So we really need a different way how to handle this. And for this, there is a new primitive that I want to share here, and this is basically database branching. And basically what the branch means is that you have your main database, and then you can easily create branches from that database. And here I'm talking more about copy and write branching, where basically what it means is that you don't really copy the data. Every time you create a branch from your main database, you just have a pointer to the parent database and don't really copy the data. And the data between the branch and the parent is shared until it changes. And when it changes, then, for example, if you change any data into the branch, then they are kept separately. So basically what it means is that it's very cost efficient with this copy or write branching, because you only pay for compute, you don't really pay for storage. And if you have some changes in the branch, you only pay for the difference of the data in the branch. So they are kind of coming for cheap if you want to run branches at a large amount of thousands of branching that kind of cost nothing for you, mainly because you don't really need these branches for a long period of time. Like we mentioned before, most of the time the agents need branches for a short period of time, so you basically need it for let's say a few minutes or an hour or so, and then you basically hibernate them. So let's see what are the benefits of copy on write branches. Some of this I already mentioned. So instant branching. So regardless of if you have a database that is 50 gigabytes or terabytes, then it takes the same amount of time to create a new branch. Minimal storage cost, like I said, you only store for the changes. In most of the cases, for example, you have a database that is terabytes of data and you create a branch because you need to test some changes, let's say like code changes, and you need to change to test it against production data. Most of the time, you don't do any changes to the branch, so basically, you don't really pay anything for storing the data for the branch. So in most of the cases, you only pay for compute while the branch is active. So with this, you have production-like data in every branch. And of course, you have full isolation. So the branch is from the user perspective, is like a Postgres instance that is fully isolated, and you can basically do whatever you want with it without affecting the main branch. So let's see how copy on write works. So basically, in the initial state, you have the main branch where you have, all this storage. In the first image is basically the storage, and then you have an index where it points to, and when you create a new branch, as you can see, only the index is copied, so that's why the metadata of the index is copied, so that's why it's kind of instant creation, because you don't really copy the disk blocks. So basically it's not full copy, but it looks like the data is copied from the user perspective. In the step 3, when you, for example, you did some changes in the branch, then only those blocks that are changed are copied in the branch, and basically you only pay for the storage of the changed blocks. So yeah, let's see how we implemented copy on write branching in Zeta. We did it at the storage layer. For multiple reasons. First of all is because we wanted to be 100% vanilla Postgres, so we didn't want to change Postgres. Also because of our experience before, we've seen that any changes you do to Postgres usually affect performance of Postgres, so we decided that for us it's important to implement copy on write branches at the storage layer. So this is behind Postgres, behind even the file system at the storage layer. Basically with this, we do the separation of storage and compute. And this is, the most important thing is that it's built for scale. What it means is that, you can easily create thousands of branches. This was one of the goals that we have, is that you can easily create thousands of branches from a Postgres. And this works. Soon we're gonna share more about how this works, but for now it's basically we use NVMe over TCP. So basically, let's see how, we have a CLI command that basically allows you to manage the copy on write branches in SATA. Of course, we have also a UI where you can do it over the web interface. But basically, my preferred way would be the CLI. So you can create a branch, and then you can connect to the branch. You can also list a branch, and like any other platform out there. Okay. Yeah, so basically, database branches, like I said, they are ephemerals. I mean, I mentioned earlier that agents prefer, like they don't really need databases to run continuously. They prefer to be ephemeral. I mean, they just need them for a shorter period of time and then they discard them. So basically for that, we implemented this feature scale to zero. Basically what allows you to hibernate branches that are not active. And this is not only for agents, but for example, if you as a developer are starting a branch to test a specific pull request, you often tend to forget to stop the branch. And this is coming handy, right? So we can have like a specific time. They say like if there is no activity to the branch for a specific period of time, 40 minutes, for example, then automatically hibernate the branch. And then with scale to zero, basically you only pay for the branch while they are active. So for us, this feature we introduced it a few months ago, and it makes a huge difference for our customers because they reduce their cost quite significantly because of this feature. So basically, as you can see here in the screenshot here, after you hibernate the branch, it will look that is hibernated in the UI, and then you have the option either to wake it up on demand from the UI or automatically hibernates or automatically becomes active the branch when there is a connection done to the branch. Yeah, basically this is what is called instant wake up. So when, like I mentioned before, when there is a connection done to the branch, it's automatically wakes up. I think everyone, like so far, it gets excited about this branching functionality. Definitely, I think probably a few of you think about, okay, how can I adopt branching? And we know that for many companies, adopting branching sounds very difficult to adopt, mainly because you don't want to move production. And we know it's not so easy to move your production database, especially for companies that have many terabytes of data. They have their, they are there for a longer period of time. So we provide a way for companies to adopt data without moving production. And in order to do that, basically, we have a different workflow that I'm going to talk in a second. Basically, it works with any Postgres. It can be in RDS, it can be RDS, Aurora, Cloud SQL, Azure, and so on. So any Postgres or even on-prem. And basically, the way it works is that you create a production clone in Zeta, and then from that production clone, you are able to create branches. So in order to create a production clone, I want to introduce you to our open source project called pgstream. And basically what pgstream does is that it does replication. So basically from Postgres to other data stores and including DDL changes. So it can do from Postgres to Postgres. This is what is interesting for our use case here, but also it can do streaming from Postgres to Elasticsearch or to Kafka or Webhook. And basically, there are two modes that supports basically one-time snapshot from Postgres to Postgres, but also real-time streaming. And basically, if you think about this, is like PG dump, PG restore, but in a smarter way. It takes a shorter time than that, but it's just easier to use and more convenient to use. And it's integrated into the SATA CLI command. So basically, in order to do the production clone, you can have, for example, SATA clone start, and then that basically does one snapshot. And then if you want to do keep it in sync, you configure the streaming. And this is what we recommend for our customers that have more than 1 terabyte of data, to do one snapshot initially and then continuously keep it in sync, all the changes from production to the production clone. And if they have less than 1 terabyte of data, then we recommend nightly snapshots. And you can do that. You can configure them over GitHub Actions. We also are working on a GitHub app that will make this easier. Also, you can also have the option to filter some specific tables if you don't want to keep in sync everything. So once you have created the production clone in SATA, then you can easily create branches from it with production-like data, and use it mainly for different use cases. So one of the use cases that our customers are using branching for is testing. So if they have, for example, a coding agent that is generating code, they want to test the code against production data, real data, before merging in production, to make sure they have the confidence that code is good and doesn't cause any problems in production. So, like I said, production branches, they contain real data, but for some companies, this comes at the risk, because you kind of give every single agent, every single coding agent real data, and especially if you have sensitive information, that can be a problem, especially for some categories of companies like health industries, or insurance companies or banks and so on. This can be really problematic. So that's why it's important to sanitize, basically to remove PII information from production data before leaving your production database. So basically, why it matters, I think it's obvious, right? Because you don't want to share any sensible information to your team or outside your production database. And it's important also to stay compliant as well. So in order to do anonymization, you can use PGStream. So the open source project that I mentioned earlier, that you can use it to clone production. And basically, it's really easy to use, right? Is automatically, so when it does cloning the production, it does on the fly anonymization. And there is I can show you that it's very easy to set it up. So you can configure the transformers, and basically, for example, you want to change the email to sound like it's a real email, but you want to change it different, and you can kind of give some rules that are in order to change those transformers. It also supports other transformers from other open source projects like GreenMask, NeoSync, and GoMasker. But for some companies, especially health industries, they have really complex rules to change the data, and for that we offer basically you can do it. You can write basically a Golang application, like a Golang script for it, and we of course we help our customers with it in order to make it easier to transform their production data. So basically, the idea is that if you want to anonymize your data, you anonymize it before it leaves production. So when you create the production clone, the data is anonymized. So all the branches that you are creating from the production clone have the data already anonymized. Yeah, so basically this is everything, the requirements that I've mentioned in the presentation. Basically, this is what we are building, we support in SATA. So like I said, it's built for agent scale. So the idea is that you are able to create thousands of branches, and we support copy and write branches. Instant startup, so basically all these branches can be created instant because our copy and write branches also scale to 0. It's important to say that we implement copy and write branches because we want it to be 100% compatible Postgres. We have the option to run it in cloud, so that our users can run it in cloud, or we also have the option for bring your own cloud. So basically, we install SATA in the customer cloud, and it can be AWS and so on, and other cloud providers, also on-prem as well. We are private beta since May 2025, and we already have customers in production. So we have kind of matured this product for a year now, almost. And tomorrow we have a new launch coming up. And I will advise you to follow us to see what this is coming. What this new launch is about. Well, we have actually a few launches that we are planning in the next few weeks. This is just the first one from a series of launches. So I will definitely encourage you to follow us to see what it's about. And also, if you want to hear more technical details about how we implemented a few things, definitely more details will come up. So I try to keep this kind of high level for now. We are also partnering with AI platforms, and why? Because the idea is that we provide a Postgres layer for them. For example, they want to offer Postgres to their users. So for example, they create agents, and the agents need to have a database, and we are helping them offering the Postgres layer. And the advantages of this is that you can run all these small databases that are required by AI platform easily, cheaply. Cheaply is important, especially that most of these AI platforms, they have a free tier and they don't want to spend too much time on a free user. And it's important to have, instant start time, be able to scale to 0 when the database is not used. And more important, depending on the AI platform, for some it's important to be able to, for the agents to also test against real data, and that's why branching is coming as an important play in this role. Yeah, that's all. I'm looking at the clock, so I was a bit over half an hour. So if you want to hear more, or if you want to stay in contact, here I'm Monica Sarbu on LinkedIn or Twitter. You can follow me. I'm mostly nowadays on LinkedIn. And yeah, you can now, if you have questions, let me see.
There is a question in the chat from Mirik. He's asking, which PostgreSQL version supports DB branching, and could a branch be easily discarded without causing DB fragmentation?
Yes, yes. So definitely we support the newer version of Postgres. You can, if you sign up, you can see all the options that we have on our platforms. And of course, branching is basically when you create a Postgres branch, you have to think of that this is an isolated environment that you can easily create and stop when you don't need it. So it doesn't cause any harm to your Postgres.
Perfect. Do we have any other questions? Looks like there was a second question in chat, but it was answered for them. And the question was, can you do PII obfuscation as a part of cloning or replication process? And then they realized, yes, it's been answered. Yes, with transformers.
Yes. Yes. Everything I mentioned to here about anonymization is part of the PG stream. So it's open source, it's part of the PG stream project that we have. But we recently acquired a company that basically they are specialized in anonymization. And for some companies in some industries, basically it's important, like if you want enterprise level anonymization, we can also support because of the acquisition that we have.
Perfect. All right. Any other questions or comments? Nope, it looks like we're good. Okay, I'm gonna turn my camera back on and I'll wrap things up. I want to thank you so much, Monica. That was a great talk and I loved your slides. They looked great. Thank you.
Thank you.
Sure. Also, thank you to PGUS and PGX. Our May speaker is Alex Uratsky, and we will email everybody when the event is available on Meetup. Upcoming conferences, our PGConf Dev is May 19th through 22nd in Vancouver, British Columbia. PG Day Boston is June 9th at the Museum of Science in Boston. PG Summit US, formerly PGConf NYC, will be September 30th through October 2nd in New York City. And PGEU will be October 20th through 23rd in Valencia, Spain. We'll send a link by email when the video is ready, and watch our social media. You can find us on LinkedIn, Mastodon, and Blue Sky by searching for Bay Area Postgres. We're still looking for speakers for 2026. We've got a few slots left. So if you or someone you know is interested, please contact us. Thank you everyone who attended this afternoon, and we hope you have a great afternoon. Thanks so much.